Hello, welcome to functions, the wonderful world of functions. All right, first let's talk about domain. Typically, I write domain as domain colon, and then it's the set, and this is all x values. Closing your set. And your range, I write it as R colon the set of all y values. Close your set. And that looked horrid. Okay. Now, these are all the set of inputs is your domain, all the set of outputs is your range. So these are all the possible x values is your domain, all the possible y values is your range. Okay? Now, when you talk about a function, we're talking about y equals f of x, or g of x, or h of x. The f, the g, the h, those are all the name of the function. So this right here is what we name the function. The x is the variable. It is the dependent variable. It is what everything depends upon. That is why when you're graphing a function, you pick the values of x. Those are what everything depends upon. So all my domain is what is dependent. It's what everything depends upon. My range is what I get out. Those are my independent variables. All right, now let's talk about increasing, decreasing. We're going to talk more about those as we go along. We're going to have relative max and mins. So when you think about, so let's talk about this for a minute. So if I have a function, so here's x, here's y, and say I have a function that goes like this. This right here is a relative max, okay? It's a max in this little set, in this little neighborhood. So it's called a relative max, and this right here is called a relative min. An absolute max would be something that would be a max for the entire function. Let's put our x and y so we know where we're going to. All right, so the next thing that we're going to do, we've talked about linear functions a little bit. The next thing we're going to talk about is vertical shifts, horizontal shifts, and those are going to be what we're going to mostly focus on in this section. We're going to talk about domain and range, and then vertical shifts, horizontal shifts, and flipping it upside down. So flipping graphs upside down. And so let's go ahead and talk about which is the reflections. And so let's go ahead and talk about, and then we're going to talk a little bit about shrinking and stretching. I don't do a whole lot of that because a lot of that's a lot harder to talk about here. What I do want to talk about, and the way that I like to deal with this, is every time I give you one of these, I want you to be able to explain to me in words what you're drawing on the graph. And so we're going to do a lot of this where you're not just drawing the picture, but you're going to have to write it out in words. Okay? So this is an online class, but it's harder in some respects because you have to be able to verbalize what you're doing. And with this being an emphasis on teacher education, you need to be able to explain what you're doing. All right, so first let's talk about domains. If your function is just simply a polynomial, not a fraction, not a square root, not anything funky, then your domain is going to be all real numbers. For all polynomials, for all polys, the domain is all real numbers. So if your thing is a linear equation, your domain is all real numbers. If your thing is a cubic, it's all real numbers. If your thing is a quadratic, it's all real numbers. If it's a 2-degree polynomial, your domain is all real numbers. So your domain here is all real numbers. And you can write it with a bolded R. That's what this 2 lines mean, is a bolded R. Or you can say domain is negative infinity to infinity. And it just depends on whether WebAssign says give it an interval notation, which is the bottom one, or they say give a set. And this is the set notation. All right. If I have a fraction, what you have to remember is that you cannot divide by 0. Okay? So that means that y plus 5 cannot equal 0. So y cannot equal negative 5. So my domain is all real numbers except y equal to 5, negative 5. Or the domain in interval notation is negative infinity to negative 5 union negative 5 to infinity. Again, it depends on what your answer is looking for. If I'm looking for a set or if I'm looking for an interval. Now, I'm going to go to number 4 because that's the next one in my logical progression. Okay? I cannot take, let me rephrase that. I can only take the square root of positive numbers, or 0. So I can take the square root, take square root of numbers greater than or equal to 0. So that means that 2x squared minus x minus 15 has to be greater than or equal to 0. So 2 times 5, 2 times 15 equals 30. So 30 is 1 times 30, 29. 2 times 15, 13. 3 times 10, 7. 5 times 6, 1. That's the one I want. So that's 2x squared minus 6x plus 5x minus 15. Has to be greater than or 0. By the way, I do know how to factor without doing this. I just tend to always do this so that I keep students so that they can remember how to do this. All right. So I have negative 5 halves and 3. So I'm going to pick numbers here. So let's just say negative 5, 0, and 4. And the reason I said negative 5 is then I didn't have to think about what negative 5 halves was. I know negative 5 is well way lower than it. All right. Okay. With negative 5, I get a negative times a negative, so I'm positive. At 0, I get a negative, and I'm just, for 0, I'm putting it there. And for 4, I get positive times a positive, so I'm positive. So my domain is going to be negative infinity to negative 5/2, and I'm equal to it, union 3 to infinity. Okay? Now, what happens if I combine the fact that I can't be 0 in the denominator and that I'm greater than 0 because I'm a square root? Then I want x minus 10 to be strictly greater than 0. So x is strictly greater than 10. So my domain is 10 to infinity. Make sure that you can combine your domains. All right, now let's look at the graphs. Now, this is going to be, what I'm going to do is I'm going to graph the basic graph in a dashed line, and then I'm going to graph the new graph in a solid line. All right? So I'm taking the graph y equals x. So this is the graph y equals x. And I want to move this graph up 2. And so that would be this line. So this is f of x equals x plus 2. So all I've done is taken this graph y equals x and moved it up 2. Right? Remember that for my functions, for something other than what I'm looking at, is I'm looking at x minus h squared plus k. Okay? So here, my vertex is 0, negative 4. And because this a value is positive, it opens up. And this is a parabola, so the shape is a U. So again, x, y. I'm going to, my basic shape is this. And I'm going to go over to 0. I'm going to go down to 0, negative 4. So that would be about right here. And I'm still going to be opening up. And so I'm just taking that basic shape and I'm moving it down to 0, negative 4. So what I need to graph is 0, negative 4. And then I need to tell you that this is now G. And that's all I need to tell you. And that this first one is y equals x squared. And that this is G. And I'm done. And so that's all I expect to see. You don't even have to tell me the dashed if you don't need to. I'm showing it to you so I know that you can see where I'm getting it from. So here's x, here's y. My vertex is 3, 1. It opens up and its basic shape is this. So my original should be this. Okay, and I go over to 3 and up 1. So here is 3, 1. And I don't change my original shape. And so this is y equals x cubed, and this is now f. All right? Okay, my vertex is 0, negative 7. It goes down, and my original shape is this. So here is my original. So here is y equals the square root of x. Okay, I'm going down to 0, -7, so let's call it there. And so this is if I just moved it. So this is y equals square root of t minus 7. But I want the negative of that, so it's going to look exactly like that, except it's going to come down here. So this is y equals negative square root of t minus 7. And that is 0, -7. Now notice how I showed you the different stages of the square root of t. Okay? And if you need to do that, then draw those different stages. Okay? All right, let's look at this one, and this should be a t. All right, the original graph here is y equals -t, and I'm going to move it down 3. So this is 0, -3. And so it should be this one. So this is h of t equals -t minus 3. Here, my vertex is -5, 0. It opens down, and it's a V. So here is X, here is Y, and I go to -5, and it's a V that opens down. So here's H, and here's -5, 0. All right? Email me if you have any questions. Thank you.